diagram, a particle A of mass 1.6 kg lies on a horizontal plane, and particle B of mass 2.4 kg lies on a plane inclined at an angle 30 degrees to the horizontal. The particles are connected by a light inextensible string which passes over a small smooth pulley P fixed at the top of the inclined plane. The distance AP is 2.5 and the distance of B from the bottom of the inclined plane is 1 meter. There is a barrier at the bottom of the inclined plane preventing any further motion of B. The part PB of a string is parallel to the line of the greatest slope of the inclined plane. The particles are released from rest with both part of the string stopped. Okay, it's released from rest. Okay, now first of all, every time when you draw when you work on mechanics or you have a problem, okay, to solve and diagram is given, please draw a free body diagram, or at least make sure that you resolve whatever forces that needed or information that you have given, the question has given. Please write it over here so that it's easy for you guys to solve the problem. Okay, so I'll draw whatever information that you have. So we know R will be acting perpendicular to the surface, and then that's W equals to mg, and that's your R, and R will be mg cos theta, and then you have W over here that's acting downward, and then you have another R over there. Okay, let's solve this. Okay, what's happening at A? Okay, at A you can see that T equals to MA. Okay, because the surface is not rough, so T equals to MA. So from there, T equals to 1.68. Whereas at B, you have, it's an inclined plane, 30 degrees. So definitely mg sine theta. Okay, and since the motion, remember, okay, motion is this way. Okay, it's coming downward. So mg sine theta minus t equals to ma, and from there we can form an equation. The weight or the mass over here is 2.5, so the weight is 2.4 times 10 times sine 30 minus t, and this is equal to 2.48. Let's solve this. Because 24 so 12 minus t equals to 2.48. This is number 2. This is number 1. Okay, solve 1 and 2, equation 1 and 2. So you will get 12 minus 1.6a equals to 2.4a. So bring that over, so you get 12 equals to 4a, a equals to 3 meter per second square. Okay, so that's the acceleration. Okay, next find t. So t equals to 1.6a, and this is 1.6 times 3 equals to 4.8 Newton. Okay, next. It is given instead of a horizontal plane is rough, that the coefficient of friction between A and the horizontal plane is given as 0.2. The inclined plane is smooth. Find the total distance traveled by A. Total distance traveled by A, 9 marks. Okay, so it's a lot of information over here. So it's going to involve a lot of working. Okay, let's do that. So first of all, mu is 0.2. Let's form another equation. So what happened at A? Okay, what's happening at A? Okay, A is on a surface, okay, which is a flat surface. Okay, the particles, it's on a flat surface, whereby B is on a inclined plane. Okay, so you have two planes over here attached together, so you have to solve it differently. Okay, let's solve this. So at A, what's happening? So T minus mu R equals to MA. Okay, just now we had T equals to MA, but now T minus mu R. Why mu R? Mu R is the frictional force. Okay, frictional force. Every time when there's motion, okay, there's a frictional force that's acting opposite to that. So I need to find the net force, I need to minus that. So T minus mu R equals to MA. So T minus 0.2 times R is mg cos theta. So sorry, this is on a flat surface, so there's no mg, it's not an inclined plane. So 0.2, you just have to times R, which is the weight. Okay, 1.6 times by 10, normal force is equal to weight. Okay, so 1.6 times by 10, and this is equal to 1.6 times by A. So T minus 3.2 equals to 1.6A. Okay, so this is your first equation. And at B, what's happening at B? At B, it's an inclined plane. Okay, let's have a look. It's an inclined plane. Okay, and inclined to 30 degrees, and the particle is 2.4 kg. So mg sine theta, okay, it's going downward again. There is the force, which you have to minus tension, goes to MA. Okay, because that surface is not rough. The surface that's rough is only at A, not at B. So you don't have to minus mu R, remember. Okay, so read the question. So this is 24 minus 24 times by sine theta. So in this case, you have 24 times by half, sine 30, which is half, minus T equals to 2.4A. So 12 minus T equals to 2.4A. This is equation 2. And now let's solve equation 1 and 2. Okay. So when I solve equation 1 and 2, it's T minus 3.2 equals to 1.6A, and then 12 minus T equals to 2.4A. Okay, when I solve this, I can add both of them, so that will eliminate T. So 12 minus 3.2, this is equal to 1.6A plus 2.4, which is 4.0A. So 8.8 equals to 4A. A equals to 8.8 divided by 2, which is 2.2 meter per second square. So this is the new acceleration. Okay, so when A equals to 2.2, from there I can find what is T. So T equals to 1.6A plus 3.2, and the answer is 6.72 Newton. Okay, use your calculator, you should be able to get that. String, when the particle B hits the barrier, okay, the moment the particle B hits the barrier, the string will slack. So there's no force or tension involved. There's no more tension. When there's no tension, what's going to happen? Particle A, slowly it will move to a certain distance and then it will stop. Why? There's no more acceleration. There's only deceleration. So I need to find certain information over here before we solve. Okay, first of all, let's find what is the velocity that it is traveling. Okay, so to find the velocity that it is traveling, so the information that we have, okay, SUVAT. Okay, I have S, okay, given 1 meter, and then I have U, it's starting at rest. So final velocity, or the velocity that it has, start moving, I don't know what is that velocity. And acceleration, we already have the acceleration, which is 2.2, and the distance or no time is needed. So let's use v square equals to u square plus 2as. So v is what I want to know. So v equals to square root of 0 square plus 2 times by a, which is 2.2, and multiply this by 1 meter. Okay, so we already have 2.2 and 1 meter. That's the distance it's going to travel before it hits the barrier. So what is the velocity that it is traveling? It is traveling as 2.0976 meter per second. Okay, so this is the velocity that it is traveling before it hits the barrier. So the moment it hits the barrier, the string will slack. When the string slacks, T, your tension for the string becomes 0. Okay, there's no tension, T equals to 0. When there's no tension, then T minus mu r equals to ma. At a, T immediately becomes 0, so mu r equals to ma. So if you plug in some values over here, 0.2 times by 1.6 times by 10, this is equal to 1.6 times by a, which we want to find the new a. Okay, this a is, remember, this a is actually deceleration. Okay, it is traveling as 2.0976, and then until it hits the barrier. So the moment it hits the barrier, the string slacks and a will move to a certain distance before it stops. Okay, so the point where it hits the barrier, the acceleration starts decelerating. Okay, becomes deceleration. So what is that deceleration? That's what we want to find. This is negative 3.2 equals to 1.6a. So a equals to negative 2. A equals to negative 2 meter per second square. So this is the new deceleration. Now we already have deceleration. Now what is the distance that's going to travel? Okay, so SUVAT again. S is what I want to find. U we already have. It was traveling at 2.0976 meter per second. V, the final stop. It's going to decelerate and then stop. So V equals to 0. And A we already have, and T we don't need that. So again, we don't need T. So V square equals to U square plus 2AS. So V equals to square root of 2.0976 square. Okay, so this is, sorry, we are looking for S. So change the formula. So S is V square minus U square over 2A equals to S. So from there, B equals to 0 minus 2.0976 square over 2 times by negative 2 equals to S. Okay, so from here, S is 1.0999, which is same as 1.1, approximately 1.1 meter. So the distance it has traveled before it stops was 1 meter plus 1.1 meter. Okay, 1 meter until it hits the barrier, 1.91 meter after hitting the barrier. So total is 2.1 meter before it stops.